Alright, welcome. This is Chapter 10 Study Guide. Feel free if you want to skip ahead to any of the problems that you're not sure about, but we're just going to go through, I'm going to go through really quick, one by one, each of these problems. Okay, this is a parallelogram. A parallelogram, the area is going to equal base times height, length times width, and the base is going to be this 19. And the height is always the line that makes that perpendicular angle, so it's 13. So to find the area, it's 19 times 13, which is going to give us 247. And again, if I don't see any units, I can just write units squared. Problem 2, same type of problem, where it's asking for the area of a parallelogram, which is base times height. Okay, you know the area of the base, which is 24, but you don't know the area of the height. So we got to figure out, well, what is this dotted line going to be? You see it's a 45, 45, 90-degree triangle, which means it's a special right triangle. So we got to go from a 90 to a 45, which means we have to divide by rad 2. And so 16 divided by rad 2 is going to give us 8 rad 2. So this is 8 rad 2. Remember, the two legs are the same. That's 8 rad 2. So we're going to get 8 rad 2. And so the area is base times height. So 8 rad 2 times 24 is going to give us 24. Once to keep it as a simplified radical, 24 times 8, which is 192 rad 2. And again, if I don't see any units, I can just go units squared. Alright, problem number 3, we got to find the area of this, and it's a weird looking shape. So what I would do is I would just start breaking this into shapes that we know. So I can draw a line here, and this is an area of a rectangle. Well, we know area of a rectangle is length times base times height, which is just 16 times 11, which is going to give us 176. So this box is 176. Well, then I'm also going to draw a line right here, because again, I have here is another rectangle. Okay, and again, I know the area of a rectangle. There's another one. Again, this height going straight up and down, well, if that's 8 and that's 11, which means that this is 19. And if this whole thing is 34, but I want to take away this 16, then I just go 34 minus 16, which is 18. So this is 18. So again, to find the area of this rectangle is 18 times 19, which means that this is 342. And the last thing that we have to do is we have to find the area of this triangle on top. So the area of the triangle on top, again, we know that this length right here, that red line, is 18. And this height, going straight up and down, that's what we need to know. We need to know what the height is. Well, again, if this whole line is 29, and we want to take away basically this portion, which is 8 and 11, which is 19, well then again, to find the area of a triangle is base times height divided by 2. So 19 times 18 divided by 2 is going to give us 171. So we have three numbers. We have 171, we have 342, and we have 176. And again, we're putting all those together, which means we are adding them. So plus 342 plus 176, and we should get an area of 689. Again, if I don't see units, I just write units squared. Next question, question number 4, is find the area of a triangle. Remember, the formula for area of a triangle is base times height divided by 2. This is going to be my base, and remember, the height is always it always makes a perpendicular angle. So again, I know that's my height, so I'm going to go 13 times 22 divided by 2, which means my area is 143. Again, I'm going to write units squared. Alright, number 5. Again, I got to find the area of a triangle. Area of a triangle is base times height divided by 2. We know the base is 32. So I'm like, alright, the base is 32, but I need to find out what the height is, which is this dotted line. And I see it's a triangle. If that's 60, this is 90, which means this is 30. So again, I want to figure out what this is. This is a special right triangle. To go from a 90 to a 30, you need to divide by 2. So this side is 10. And to go from a 30 to the 60-degree side, you have to multiply by 3. So the height is 10 rad 3. And we want to divide it by 2. So it says keep it as a radical. So we're going to have 320 divided by 2. And this is going to give us 160 rad 3. And again, if I don't see units, I'm going to write units squared. Okay, next one is the area of a trapezoid. Now, area of a trapezoid is the two bases added together times the height divided by 2. Now, how do you know which side of the bases? They're the two sides that are parallel to each other. So 10 and 14 are my bases. So I'm going to go 10 plus 14. The height is always that line that would make a 90-degree angle. That would be this 6. So times 6 divided by 2. So we're going to have 24 times 6 divided by 2. And this is going to give us 72. And again, if I don't see anything, units squared. Alright, on problem 7, again, we still have a trapezoid, but it's giving me a couple things. So I have the formula, and I'm just going to start plugging in as it tells me. It tells me the area is 540. So that's where I'm going to put it on area. It says the perimeter is 71, and if one leg is 17 and the other leg is 18, then find the height of the trapezoid. Alright, let's just draw one of what this looks like. Okay, it says one of the leg is 17. Now these are the two legs, the other one is 18. Okay, and we want to find out what the bases are, right? This would be like base 1 and base 2. Okay, well, there's 4 sides, right? And the 4 sides are all going to add up to 71. That's what the perimeter means, all the way around. So if I take 71, and if we subtract 17 and 18, then we get 17 plus 71 minus 17 minus 18. We're going to get, this is 36. Now, both of these sides added together are going to equal 36. Do we need to know what each side is precisely? No, because we want to add those up anyways, but both of those added together are going to be 36. Okay? And it tells me we want to find out what the height is. We don't know what that is, and we have to divide it by 2. Okay, so now my goal is just to get h to be all by itself. So first thing I'm going to do is I'm going to get 2 out of the denominator. So I'm going to go times 2 to both sides. So 540 times 2 is 1080 equals 36h. Divide both sides by 36 means that the height is going to equal, the height is equal to 30. And I don't know why it says area, because it told me to find the height. So we want to find the height is 30. 30 units, or we can write 30, or again 30 centimeters, because we're talking about centimeters. Number 8, we just got to go, it says a rhombus. A rhombus looks something like this, where all the sides are the same. So it's a type of parallelogram. And it says one of the diagonals is 13, and the other one is 19. Well, again, my formula just says take the two diagonals and multiply them together, so 13 times 19, and then divide that by 2, and we should get 123.5. Again, we're talking about inches, square inches. And just remember that the diagonals is from one angle to the opposite angle, one angle to the opposite angle. Those are my two diagonals. Okay, number 9, it says find the area of a rhombus with a perimeter of 36. Well, the thing you got to remember about a rhombus, though, is that all the sides are the same. So if they're all the same and they're all 36, if I go 36 divided by 4, it means that each of these sides is 9. Okay? And it says one of the diagonals is 12. Okay, cool. Well, we know one of them is 12. I just got to figure out what this other diagonal is. Okay, but if this whole thing is 12, we also got to remember though that the two diagonals, they bisect each other, which just means that that portion is the same length as that portion. And if this whole thing is 12, then if it's cut in half, then this has got to be 6 and 6. The last thing you got to remember about a rhombus though is that the middle always creates a 90-degree angle. Okay, so we should stop right there. We should see, all right, well, what type of shape do we have? We have a right triangle, right, where this is 9, this is 6, and we are trying to solve for x. Okay, if you have 2 or 3 sides, you can use Pythagorean theorem, which is a squared plus b squared equals c squared. C is always across from the 90. So x squared plus 36 equals 81. And 81 minus 36 is x squared equals 45. And if we take the square root of 45, we're going to get 3 rad 5. So x is equal to 3 rad 5. Oops, 3 rad 5. But remember, that's 3 rad 5. But remember, that's only half of it, though, right? We need 2 of them, right? So we got to take this 3 rad... Ah, dang, I keep messing up. We need to take this 3 rad 5, and there's 2 of them. So we need to times it by 2, which means that it's 6 rad 5. So again, we're going to have 12 times 6 rad 5, because one diagonal is 12, the other one is 6 rad 5. And again, if I keep this as a radical, I'm going to go 12 times 6 divided by 2, and this is going to give us 36 rad 5 centimeters squared. Alright, so now we get into the area of a regular polygon. It's a regular pentagon. A pentagon's got 5 sides. And area equals apothem times perimeter divided by 2. So it tells us first the side length is 30. Well, again, to find the perimeter, if there are 5 sides and each of them are 30, then again, all I need to go is 5 times 30, and we're going to get the perimeter is 150. Cool, I got perimeter. Next thing I got to do is I got to find the apothem. Well, remember, the apothem goes from the center and it cuts the angle in half. It makes a 90-degree angle. Well, what is this central angle? Remember, all these angles inside, they always make 360 degrees. Well, if they're all the same and there's 5 different angles, because there's 5 different sides, then we go 360 divided by 5, which means that each of these are 72. So like, again, that's 72, this one is 72, and we keep drawing it. But this apothem is going to cut this 72 in half. So 72 divided by 2 means that we have 36. And this one is also 36. So again, my goal is to find this dotted line. Remember that each of the sides was 30. But this is 30, but this apothem cuts this 30 in half, so we get 15, and this is 15. Alright, so like, alright, I gotta find out what this dotted line is. We should see that we have a triangle. Again, it's a right triangle. This is 15, this is x, and this is 36. Okay, that's not a special right triangle, so we have to use our trig functions, which is our SOHCAHTOA. Okay, and our SOHCAHTOA is saying that this is a circled angle, this is opposite, this is adjacent, which means that we are trying to solve for the tangent. So the tangent of 36 equals opposite 15 over x. I times both sides by x, and I get x times the tangent of 36 equals 15. And then we divide both sides by the tangent of 36. And so we get 15 divided by the tangent of 36. And this is going to give us the apothem is equal to 20.6 20.65, let's say. So we have the apothem, which is this, again, 20.65. The perimeter at the very beginning, remember we said was 150. I take those two and I multiply them together, and then I divide it by 2, and the area is 1,000 right here, 1,548.43. And again, if I don't see any units, I have units squared. Again, depending on how you round it, we'll probably be pretty close. Again, I kept, even though I wrote 0.65, I kept all the decimals. So this is my most precise answer. But if you have a couple tenths off, it should be about that answer. Alright, 2 left. Okay, again, we're doing the same thing. This is a heptagon 7. Okay, again, if you don't know what that is, as you know, I don't expect you guys to memorize it. But all of the figures, again, we should just draw a triangle. I don't have to actually draw a heptagon. I'm just going to draw one of these sides. It's always going to end up being there. And it says it has a side length of equal to 16. So again, I can find the perimeter first, which is 16 times 7, which means that the perimeter length, 16 times 7, is 112. Okay, again, we have all these angles on the inside of a heptagon. They're always going to add up to 360. And if we take 360 divided by 7, it means that each of these ones are going to equal 51.4. So they all equal 51.4. And again, remember though that we got to cut this in half though, because this is my apothem. So we're taking that 51.4, which is all those angles, and if you take that and divide it by 2, then we're going to get about 25.7. Again, we'll round it to the nearest tenth. 25.7. And this side length, which was they're all 16, remember this gets cut in half to be 8 and 8. Okay, we have our right triangle. Again, these problems kind of take a lot of different steps to get there. But if you have 8, we're trying to find the apothem, and this is 25.7. Okay, we have to use our trig functions, which is our that's an h, that's another h, toa. Again, I have opposite over adjacent, which means we have to use our tangent. So we're going to find the tangent of 25.7, so of the angle, equals, opposite is 8 over x. I multiply both sides by x, and then divide by the, so let's just do that, times x. We won't skip a step. 25.7 equals 8, then divide by tan 25.7, and that's what we're putting into our calculator. So you have 8 divided by the tangent of 25.7, and we're going to get the apothem is 16.62. Let's just say, we'll round it. And again, that's my apothem. The perimeter at the very beginning we said was 112. We take those two and we multiply them together, so times 112, and then we divide it by 2, and we should get, again, depending on how we round and when we round, we should be pretty close to 930, let's say 0.8, round to 2 decimals, 8. And again, if I don't see any units, I'm just going to write units squared. Alright, our last problem right here, number 12. Okay, it says that the perimeter of a rectangle. So remember, when we're finding this though, the perimeter and the scale factor is going to be alright, so let's just draw a picture first. So again, I have a picture, and I'm like, alright, to find the perimeter, all these sides, they're going to make 24. And the area, again, I got to remember, area is base times height. That's going to equal 27. So if I'm just thinking, well, what times what's 27? Again, well, I'm like, well, 3 and 9, right? If this is 3 and this is 9, that makes 27. And so, if like, well, does that mean that this is the perimeter, though? Let's see. Remember, in a rectangle, opposite sides are the same, and opposite sides are the same. So if I take 9 plus 9 plus 3 plus 3, I get 24. And that's what the perimeter was. So what is the base and the height? Well, the base is going to be 9 and the height is going to be 3. Okay. If you have any questions on any of these problems, because I know some of them are tough, please make sure you ask before the test. Okay. I hope you guys helped. Questions, let me know. See you guys soon.